So in example 4, we're asked to find the equation of the tangent line of f of x equals sine of ln of x minus 3 at the point x equals 4. So we're going to use this tangent line, which is a blue line, and then part B, we're going to use this blue line to approximate a point on the curve at 4.1. So we're going to use the blue line to approximate the point that's on the curve at 4.1, and you can see from the graph it's actually very close. Okay, so we want the equation of the tangent line. So to do that, we need an x and y coordinate. So I've been given x. So calculating y, when I plug in 4 into this equation, I get 4 minus 3, or log of 1. Log of 1 is equal to 0, and sine 0 is equal to 0. So I know my coordinates at 4, 0, and again, my graph actually confirms that. Okay, so that's the point of tangency. We need a derivative to calculate the slope. So differentiating this, I need to differentiate the outside. Okay, so I don't touch the inside. And then I need to multiply by the derivative of the inside, which is 1 over x minus 3. So there's my derivative function. I'm going to calculate the slope at x equals 4. So I'm going to plug 4 into this equation. So I get cosine of log 4 minus 3 is 1. And this becomes 1 over 4 minus 3, which is 1. Okay, so working this out, cosine of log 1 is 0. The cosine of 0 is equal to 1. So that means the slope of that tangent line is equal to 1. And again, if you take a look at the picture, you can see that the slope of that line is equal to 1. So that confirms our result here. And we need the equation of the tangent line. So to find the equation of the tangent line, to use point-slope form, I need the point and a slope. So I have the slope, I have the x-coordinate, 4, and I have the y-coordinate, 0. So that's my equation of my tangent line. So that's part A. Part B says we're going to use this tangent line to approximate a point at 4.1. So what we want to do is find the y-coordinate on the blue line when x is 4.1. So this works out to be 0.1. So on this line here, we know that at x equals 4.1, so 4.1 is right there, y is right on that point at 0.1. And that point is just a little bit above the red line. So it's not quite exactly the same of f of x, but it's pretty close. It's a slight overestimate. So we're going to say that f of x, so f of 4.1, is approximately equal to 0.1 because it's pretty close. Okay, we estimate it's with that's the point on the blue line, and it's very close to the point that we would say that should be on the red line. We know that's not exactly the same, but it's pretty close. So in this example, we're going to do the same thing. We're going to find the derivative, just like we did here. We want to find the slope at that point. Okay, so in this case, the point that we're given is at 1, 0, okay, right on the x-axis. And we're going to use that line to approximate the point on the curve at 1.1. So the first thing we're going to do is differentiate this. So we're going to find the derivative. So I'm going to differentiate the outside function, log. Then I'm going to differentiate the inside, x squared plus y. So x squared differentiates to 2x. When I differentiate y, I'm going to end up generating my derivative. And then that's equal to 0. Okay, so I'm going to solve this equation. I can basically, if this equation is equal to 0, the numerator should be equal to 0. But before I get rid of the denominator, I need to state a restriction that y is not equal to negative x squared. Okay, so as long as y is not equal to negative x squared, I can solve this derivative and say that 2x plus y prime is equal to 0. That makes y prime equal to negative 2x. So I can use that as my derivative. I want to find the slope of that line at x equals 1. So I'm going to find y prime at 1. And the slope of that line works out to be -2. So taking a look at that graph, yeah, that slope looks like -2. So that looks correct. Okay, so I'm going to find the equation of the tangent line now. So I have the slope. So it's going to be y equals -2. And I have my point at 1, 0. So putting it in the point slope form, I've got now my tangent line. And again, using this tangent line, I'm going to use that tangent line. I'm going to find a point on that tangent line at 1.1. So it looks like that point is right there at -0.2 and 1.1. Okay, so finding the coordinate there, I just plug into my equation, 1.1 minus 1. So that's going to end up being -2 times 0.1 or -0.2. Okay, so that's the point on the blue line, and that's pretty close to where the red coordinate should be. So then that's my estimate. I'm going to say that f of x at 1.1 is approximately equal to -0.2 based on my tangent line approximation. Now, given this function, we probably could have, once we see the function, we could have guessed that this is actually a -x² + 1 graph, and then we could figure out the exact value based on that. But we know that exact value is going to be pretty close to -0.2 using our tangent line approximation. So the tangent line approximation is using the tangent line, finding a point on the tangent line and saying that's an approximation to the actual curve at that point.